Hello. Welcome to the Building Diverse Data Communities with Jupyter Notebooks session. I'm Dr. Patrick Phelps.
My name is Frances Haugen.
And we both work at Pinterest. So I am the head of data science for our partners and ads team.
I'm a product manager working on ranking for the home feed.
Yeah, one thing that might help you guys a little bit of context on this, for each of us to talk about a problem we work on today. So for instance, I think a lot right now about how do we build a unified auction for organic content and the various forms of advertiser content that we have on Pinterest.
As a data product manager, the thing I focus on is working on building user-oriented algorithms. So historically, we've only optimized for how likely you are to save a pin. We're moving towards more user-driven goals like variety. Like people like to see a variety of different things. It's how they keep from getting bored. That's the kind of thing that a data product manager works on.
Cool. So we want to start this talk with a question, which is, what if data science, which today is a very centralized practice, could be as decentralized as software engineering has become, where people all over the world contribute to it in a meaningful way?
We'd like to start out by asking a question. How many of you work at companies where there is an isolated analytical function? So you might call these people data scientists or analysts or business operations analysts. Like we definitely do. Yeah, most people who work in software work at places where analysis and quantitative investigations are isolated into these functions. The reason for that is manyfold, and we're going to go into that, but there's a lot of consequences for this organizational decision. The best kind and most impactful kinds of data science insights are ones that join both rich, rigorous statistical tools with subject matter expertise. The best question that you're going to ask, the best investigation you're going to do, does not start from the first question you ask, but often the second or third or fourth question that you discover as you go down the rabbit hole of that investigation. When you isolate out into its own function, the analytical investigations, usually those investigations end with that first question. You'll ask an analyst to go find you an answer to a question, and they'll bring you back the answer to that question. Really good analysts will often do another hop down that line. But they very rarely will go with it with a level of persistence or curiosity that someone who is actually immediately working on those problems would do. The other challenge is that a lot of companies try to get around this by having analyst managers, data science managers who functionally act as almost like anthropologists. They'll go in there and ask you all these questions about why you want to know this, and what are you going to do with this, and what have you asked before? And it's because when you isolate out this function, you actually have to have a huge amount of communication overhead to actually get enough context to get good answers. So what's the alternative? Patrick and I are very big advocates for what we call heterogeneous data communities. So in any organization, even outside of software, you have a wide array of stakeholders who could be effective users of data. Not just consumers, but people who actually go and ask questions and solve them using data. A heterogeneous data community doesn't require everyone to have a statistics PhD. It has organizational practices and tooling that allows people to go and be these equal participants, or at least be able to ask informed questions.
So why doesn't this happen? Why do we have analytics teams today? And the basic answer comes down to that data science is hard. And in sort of the course of our time doing data science, we've identified sort of 4 core reasons data science is hard today. So the first is that most data sources we have in the modern world are incredibly opaque. A classic example is like a relational data store, think SQL. When you access SQL, there's some tables. These tables have some columns that have names. At the simplest level, you really hope those names describe what's in the columns, because otherwise, heaven help you. At a more complex level, we often have opacity because really subtle bugs end up in the data. You know, last year in August, there was a logging drop for these days, or the client mislogged this kind of event. Did this table get backfilled to fix that, or did it not? What about this other table that I want to join on? Are they actually both spam filtered? Are they spam filtered with the same algorithm? These sorts of questions consume massive amounts of sort of brain power. Like people have to hold this in their heads. But this is only one reason. Even if we had perfectly transparent data sources today, which we don't, there's a serious problem that in any organization, you're going to have people at different levels of sort of analytical ability. This can range all the way from someone who has been doing data science for 10 or 15 years, and kind of knows all the statistical methods you could possibly hope to care about, down to your salespeople who might be, looking at some dashboard and trying to decide, like, in this, for example, this plot, like, is this going up over time? Is it good for our advertiser? Maybe it's just noise. Is it real? All of these sorts of things are different skill levels in an organization, and we think it's important that, like, all of these skill levels can contribute. Part of what makes that skill level gap so hard is that spreading best practices today in data science is a really, really complicated affair. What tends to happen is that, there's these sort of experts. They sit in one part of the company. They work on one specific thing. And then they have to go to a bunch of meetings and talk to people. And what happens is they go to meetings, someone else has done some analysis, sort of everyone in the room is like, what does this data scientist think? The data scientist makes some proclamation or some comments, and then the entire thing has to repeat. And your data scientists end up sitting in 1-hour meetings, 2-hour meetings, multiple-hour meetings. It's very inefficient for their time. And the way companies normally try to get around this is they want to just develop some training. And we've actually, been doing this ourselves, and we can tell you immediately that doing meaningful training is really hard. In order to gain data science skills, you often need many hours of focused training. And the people in your organization you need to work with data can't spend the time. No one can afford to send all of their salespeople to 10 or 100 hours of training, and no one wants them to spend that time that way. Even worse, it's very demotivating. No one wants to be like, oh, I'm going to spend my first 4 weeks at the company doing training. People want to actually experience their job. They want to develop in that way. They want to work with peers. So all of this brings us to the core message, which is that data science today is very hard.
But in reality, there's an even bigger problem, which is that people are harder. Data science fundamentally involves trust. There's lots and lots of ways an analysis can go wrong. Maybe it's how you pulled the data originally. Maybe it's how you picked your statistical techniques to analyze it. Maybe it's understanding the limitations of those techniques and whether or not your problem is actually a good fit in the edge cases. And then in the end, because numbers are so beguiling, because we like to believe that numbers are true, they're dangerous, right? People look at numbers and they believe they're objective. And as a result, a finding can propagate itself very, very quickly throughout an organization. Because data analyses are often catalytic, they are both incredibly important because they can change the direction of your business, but they're also a high risk because if that analysis was done incorrectly, suddenly a whole cascading set of actions may take place. One of the things that this results in is that trust is guarded very preciously. We know with great power comes great responsibility, and we want to make sure we pick the people who we give that responsibility to intentionally. One of the possibilities for how you could spread out this functionality, though, is by just having some skepticism. I began my career as a not very technical product manager. I had an engineering degree, but I worked on ranking systems at Google. And within search, you had all these people who had been working on search and information retrieval problems, sometimes for 30 or 40 years. How are you going to trust a 22-year-old who can kind of barely write SQL? How are you going to trust the findings of someone like that? So back then, our tooling wasn't as good. And an experience that I had over and over again is I would go and do an investigation and find something that looked novel, like something that looked like we could go and maybe pursue that or dig deeper. And I would bring it to someone else and I would show them this chart I'd made. And if it was novel, which is the reason why you'd want to do an analysis, it would be immediately disregarded. There were so many ways that I could mess it up. There was no way I could be an effective contributor in that way. Part of the reason why this happens when you have the wrong tooling is people feel really bad feeling skeptical, right? Most people are not very confrontational. You're not going to go when someone brings you an interesting graph and say, could you send me all the code that generated this? Can I see your work processes? Or especially if someone used a spreadsheet to process, say, a SQL query, even if you get the SQL query, you have no idea what transformations that data undertook to result in the final graph. Because people are conflict averse, the end conclusion is exactly what happened to me when I was 22. People just ignore the people who are kind of outside the center circle of trust. The last issue on the human side, the organizational limitations side, is around documentation. How many people here like writing documentation? Okay, we got a few. My personal career tip is documentation is amazing because you can learn anything if you offer to write someone else's documentation. People will sit and explain at great length and in great depth any topic you want to learn about if you're willing to write for them. I don't mind it. That's how I've learned most things. At the same time, documentation can't exist only in those isolated circumstances. You need ongoing processes of documentation because data science is fundamentally a communication activity. Without doing information capture, knowledge capture around what are the caveats of an analysis can become very, very dangerous. If you ever have a conversation with a data scientist, they will have lots of limitations on the thing that they've just said. They'll say, yes, this is true, this could be true, right? Or it appears that this is true. And somehow, as you write that email and it propagates out 3 or 4 times in a forwarding chain, suddenly the thing that's going to save the company is doing X. Like, this is true, not it could be true in these circumstances. Being able to get people to actually write rigorous documentation of the assumptions they undertook and have that move along with an analysis is a very, very hard problem. As a result, we end up isolating the function of analysis even further and limiting who gets to participate to the people who wear those official data hats.
So what's the alternative? Maybe before we do that, though, I'm a manager of data scientists, and I want to just reiterate what Francis just said. I worry extremely much about my data scientists becoming isolated. And the reasons are twofold. One, when they're isolated, they tend to feel disconnected from the work they do, and they don't stay at the company. And two, when they leave the company, all of that history that was kept in their minds walks out the door. So we need an alternative, okay? Like, you can't have some person who's been at the company 6 years be your backup, right? And so what we want to talk about is how can we get to that alternative? So we've already covered why data science is hard from a technical standpoint, and we actually have a pretty good analogy for this. If we think about what data science is today and the tooling that exists for it, it's actually very similar to how software engineering was practiced in 1980, in the early 90s, before we developed such tools as, open source, before we developed things like GitHub. And in fact, that transition was so powerful for software engineering, and we need that transition for data science. So GitHub was really powerful because it made code bases really non-opaque. You could go look at any open source piece of code in GitHub and see how someone did something. You didn't have to trust what they said. You didn't have to be like, oh, I heard a rumor that so-and-so did this thing, we should do it. You could just go look. We also developed practices like code review. Code review is incredibly important. It makes software consistent. It upholds standards. Today, most analytics groups don't have anything equivalent to code review. We also, from tools that we have developed like IDEs, we get extensibility. We can search what others have done. We can copy and paste it in its most simple form. But we can also reuse it. We can modify it. We can tweak it. We can understand why something was done this way, and we can change it. And finally, one of the most powerful things that happens with code review and with these tools is you get a peer feedback process. People learn by talking to more senior software engineers, getting code reviews from them, these sorts of things. But there's still these social issues, right? How are we going to tackle these social issues? And one of our actual rather interesting theories is that what if we could tackle these, and there was something that could unlock data science like GitHub has unlocked software engineering? And our core question is, what if these social issues aren't social issues? They're tool issues.
And that brings us to tooling. Data-intensive communities are incredibly sensitive to the tool choices they make. Most of us have been told, most companies navigate this issue of how do we make data decentralized? How do we make it accessible to people by going out and paying a vendor a truly huge amount of money to gain some kind of new dashboarding tool? Maybe it's Tableau, maybe it's one of the many, many other providers. It seems like there's a new startup at any given moment that says you can do anything with our dashboard. The problem with dashboards is manifold. So the first is any dashboard that has a low enough barrier to entry that people in general can use it also doesn't have a long enough runway that people can become independent. The second one is that any dashboard that you see that you don't actually make yourself has assumptions baked into it that you can't actually work backwards from. So like we talked about before about how part of why data is dangerous is that it feels objective. There are implicit choices that are made whenever someone designs a dashboard that you can't actually step back from. Very few dashboard systems allow you to peek back from behind the curtain and see what assumptions or what processes went into producing any given graph. The secondary thing is even thinking about how you're going to think through a problem can be shifted by the visualizations that you're presented with. When someone goes through and makes design choices about how to walk you through a cognitive process in a dashboard, you're probably not aware of how you've already had biases introduced into how you're going to even think about solving these problems. The second danger of dashboards is that we have trouble understanding the genealogy of any given dashboard. So even let's say it's designed just right for your use case, let's say it's using the right methodology, you still have this problem of, let's say you're asked to go find the 20 best-selling widgets on the West Coast. And you're like, oh, I have a dashboard for that. And we'll assume the dashboard is actually objective and good. You can go look it up, and maybe while you're looking it up, someone will come by and say, oh, interesting. Is that the dashboard from 2008? Like, no one uses that dashboard. That dashboard's totally wrong. And you can be like, well, it's on the wiki. Like, I searched for it. I heard there was a dashboard. The wiki said there was a dashboard. When you have systems that make it very easy to generate dashboards, it's true that you can at least diffuse information more effectively. But if you don't have a way of actually tracking or understanding when things go stale or when they expire, you end up introducing some problems that can be just as worse as people not having access to that data in the first place. The last one is Spreadsheetzilla. So this is the way most companies do analysis when you do give people the ability to do ad hoc analysis. People go and write an SQL query. They dump maybe a file of data somewhere. Maybe they play with it in a spreadsheet, and then they generate a graph. And maybe there's even a third transformation step that happens. Maybe they write up an email that just has that finding, and maybe the graph pasted in, or maybe a slide. The problem with this is anytime you start sending a spreadsheet around, eventually you encounter another spreadsheet that says something else. And suddenly you might find yourself in the situation where your boss is asking, Jane had this spreadsheet and you have that spreadsheet. Which spreadsheet is right? If you don't keep together and you don't keep a way of tracking the genealogy of where your data came from, how it was processed, and what the end result was, you have no way to go and work backwards and be able to debug why are the numbers no longer agreeing. The thing that we actually want people to have is what we call data independence. We want them to be able to access data in a way that is flexible enough that they can ask their own questions, but at the same time is accessible enough that we can get as many people as possible empowered to ask questions in the first place.
So what is an alternative? At Pinterest, the alternative we're trying is the Jupyter Notebook. Now, I hope most people in this room have heard about the Jupyter Notebooks and have some idea what they are. But just in case, what Jupyter Notebooks are is an open source software project that allows you to combine richly formatted text, data, and code all in one place. And we'll show some examples of what they look like in a few seconds. What's most important to understand about Jupyter Notebook, though, is that they were designed from research groups. They were designed from academia. And that's actually a really weirdly good thing. Most things we don't actually want what academics design. They're not very good at coding. I was an academic, I can say that. But it turns out for this is the culture we need. And this interactional environment is really powerful because it combines all these things. And the reason it was developed this way is that research groups today operate very much how companies need to operate. When you are doing some sort of data analysis in a research group or in a company, you're going to have wildly different skill levels. And in research groups, these are, for instance, the professor. The professor has been doing this research for 40, 50 years, right? Has seen all of the evolution, but has very little time. Then, the professor has postdocs, they have grad students, and they even have undergrads. And undergrads are coming in the door, possibly right out of high school, and have very little experience with working with data, understanding what is going on in the scientific process, and all of these sorts of things. And this is very similar to how analytics functions can operate. You need to have a tool that encourages new people should come on board, and they should be productive from day one. They should figure out how to use the tool. They should be able to scale. So let's talk about some examples, right? So one of the things Jupyter Notebooks allow us to do that's really powerful is they allow us to combine these various pieces of information. So in this case, for instance, we're seeing a viewer of a 3D plot, right? This is a way to visualize a probability distribution. So we can do stats, but we can also see like, how was this plot generated? We can see why does it appear the way it does? We can ask like, as they asked in this notebook, what happens when we rotate the sample? All of these sorts of questions are suddenly possible. You cannot do this if this plot is in a spreadsheet, right? Or if it's in a slide deck. You might be like, well, it's a two-dimensional representation because that's what our tool can generate, and I hope that was enough information. You can also combine many forms of rich information. So you can combine different forms of media from outside the company, from internal, and you can combine them with rich text. Finally, one of the things we've really found powerful at Pinterest about Jupyter, and the notebook in particular, is you can have plots like this. You can have plots that are incredibly informationally dense. They are not histograms. They are not pie charts. They are not line charts. Instead, they are designed to tell a story around the data you need to tell the story of. Okay? So this is incredibly powerful because like this plot is unreadable to the people who probably haven't worked in this field before. But if I can suddenly have a whole bunch of stuff in the same source that tells you how to read this plot, what conclusions I drew from it, and why, you can actually start to learn how do we use these kinds of plots? Why are they important for the function? So what are we doing at Pinterest?
So Pinterest uses, actually, before we dive into how we use it, because I know our audience is largely male, and in the United States, our users are primarily female, they're not internationally, I will spend a little bit of time explaining what Pinterest is. So Pinterest is a discovery engine that people use to plan decisions about their lives. That might mean what they're going to eat for dinner. It might mean where they're going to go on vacation. Maybe how they want to dress, how they actually want to present themselves to the world. We have more U.S. users than Twitter does, and we have 200 million monthly active users around the world. Our data corpus, which is why I joined, it's a beautiful data set for those of you who love data, has over 30 billion pins that have been curated by humans into hundreds of millions of boards containing billions of connections. And that interconnected graph unleashes all sorts of interesting possibilities from an algorithm standpoint or from extracting meaning. It's a really, really cool data problem. But that means we also do a lot of data science. The way we integrate Jupyter Notebooks into our development flow comes at every single point of the product development process. At the exploratory phase, we use Jupyter Notebooks to be able to begin to validate initial ideas, or maybe even just understand an anomaly that might lead to a thesis. We use them to socialize and build consensus. We use them to analyze and monitor experiments. And then after launch, we use them to also do ongoing monitoring. In each of these phases, these kinds of analyses largely fall into three kinds of buckets, or these use cases. The first one is investigatory analysis. That's those asking the initial questions. Extending dashboards is about being able to not have to commit before beginning to socialize a metric. And routinizing and recurring analysis is about how do you free up capacity that used to be spent on analysts doing the same thing over and over again. To give you some examples of how we use investigatory analysis, maybe you have a question that's as simple like in discovery of how many impressions should our top content get? I did a long analysis that was able to incorporate not just the initial analysis and identification of which pins were on top, but because we can render rich media into notebooks directly, I was also able to build a visualizer that allowed us to actually see which pins got the most impressions. Ooh, our clicker's not the best. One of the places that it's most directly tied into our workflow and has been the highest impact is often in the process of answering new kinds of questions, you won't necessarily know how to monitor or investigate things at the beginning. How many of you have ever wanted a metric really badly on your dashboard and had to write some proposal or have your team write some proposal to a centralized group who maintained the dashboard, justifying why this thing that you needed was worth their time? Like I've done that before. One of the things that Jupyter Notebooks have allowed us to do is we can have whole analysis suites that are, we should eventually move them into our central dashboards. But as we decide how we want to tune them or how we want to use them in our day-to-day processes, instead of having to be absolutely certain before something gets distributed, maybe it has to live as just a SQL query for a long time, we can have notebooks that are very easy to run and very rigorous that we can use to distribute best practices. And then the last one, and this is the thing that has probably changed the lives of our sales team the most, or has allowed us to be much, much better communicators cross-functionally, is when we do major experimental changes on the organic side or on the advertiser side, small changes to how we do ranking can have dramatic impacts on our partners. We've developed a very rigorous analysis suite that allows us to poke at lots of potential consequences whenever we launch an experiment, and be able to even identify which advertisers we're going to have to reach out to and do comms with before a change ships. These kinds of reports have made it so that we can have a much, much more rigorous launch process, and it means that we no longer have to have a team of analysts who are dedicated just to doing this thing. We've built out a centralized report server that allows us to take Jupyter Notebooks and templatize them so that you can just change a few fields and generate the exact same analysis again. And the thing that separates this Jupyter server, as we call it, or Jupyter report server, is that unlike your dashboard, you can push a button and see the guts that actually generated this amazing report. You can always keep the context tied to the final results, no matter what. And this actually has consequences beyond transparency or code review. It means that if someone sees a plot or sees an analysis that is meaningful to them or something that they want to modify themselves, they can push a button and peek behind the curtain and now reuse large chunks of code in their own notebooks to do things in the future. You may look at that and say, well, if you're going and building centralized reports or like doing dashboards again, isn't that kind of going against this idea that people should be going and asking questions on their own? And the way we've kind of reconciled that is the way we think of all users of data at Pinterest is they kind of fall into three buckets. There are people who are consumers, there are people who are producers, and there are people who are both. When I talked about the idea that you could push a button and peek behind the curtain, that's an illustration of a philosophy that we're very passionate about, which is that we always want to make sure there is a path to mastery available to users. We're right now building out a new generation of our dashboarding software, so we do still have dashboards internally. We will always have dashboards internally, but even for those nice, polished, official dashboards, the kind of things that do our financial reporting, one of the things that we've insisted on including is a button that actually allows you to convert this nice, polished dashboard back into Jupyter Notebooks so that you could have a notebook that could reproduce an analysis if you wanted to dig further yourself.
Okay, so there is still an important point, which is even if we have this tool, we're still going to need data education for our workforce. It's still going to be important. And we've already told you why we think this is hard. But I think one thing we want to talk about, too, is that we have actually now been running a data science course at Pinterest. And I have been surprised how effective it's been. So what are we doing and why? So we talked about education being hard.
Sorry,
and
the smoke.
We going in, we had taught workshops. We knew like these were serious problems. And we decided to actually try and build a course from the ground up to address these problems. So what we did is we went out and talked to people who teach computer science. We went out and talked to people who teach physics. We went out and talked to people who teach machine learning, both in academia and professionally. And we just talked to them about like, what do students learn? How do they learn it? And what we came up with was sort of a templatized system that tries to get around these hard points. So the first thing is, this is all taught with Jupyter Notebooks. It, in fact, is not really much work for us. We, in fact, have people work through these in a peer-reviewed setting.
And it was a lot of work for us to set up.
And we don't really have to do anything in them. So people get this interactive, collaborative, and sort of scaffolded approach from the beginning. People also get a self-paced approach. So we don't have to be present for them. We don't have to be up here giving a slide deck to every single person who wants to do this. I honestly admit, part of what people get out of this is they get 6 notebooks written by us. So they get all that code, and they can go and use that code. They can see how we did things. They can reuse it, right? If all they do is copy and paste, that's fine. And finally, what's really exciting now is we're actually entering a new generation of the course where it's entirely taught by TAs. So we don't even have to show up anymore, which is a great bonus for me. So this is how we split the course. We have foundational skills in the first 3 sessions, and then we have practical data science in the next 3 sessions. And we run this course ideally every 2 weeks on a cycle. So if people need more time, maybe they get stuck on lesson 3, they can just wait. And in a few weeks, another course will come around for them in the same session, and they can do it again with different partners. To give you a sense of sort of the scale we're running this at, this is one of our recent classes. You'll notice that's one of our TAs talking to someone. All of this is sort of student-driven. It's an experiential experience. They have to help each other. They have to figure it out. We give them little prompts. We give them, they can highlight to reveal answers. We're not going to ask them to get stuck. But we only talk for about 5 minutes. It's kind of nice. I go get a coffee most of the time. So what's really important and what's really made this work is that all of the lessons are Jupyter Notebooks, every single one. That's all they are. And what we've done is we've sort of created, a scaffolding. And it starts out really strong. In the beginning, we asked them to do very basic things and to discuss why they did them. And by the end, people really gain skills. So in our first class, we had several people in our company who didn't know how to read a histogram. They had always felt uncomfortable asking that question. And in the course, for the first time, they were able to ask it, right? We had a prompt that was like, what does this plot mean? Talk to your partner. And people revealed this fact. And by the third class, people could read empirical cumulative distribution functions with error envelopes, have intelligent conversation about their differences, and actually use them in their real jobs. And when we post these publicly, we always use GitHub to do it. And the reason we do is it renders very nicely. And it is important, especially when working with more junior people, that they don't come in and stare at a terminal. They don't stare at Sublime. They don't stare at an IDE. What they see is something nice that looks kind of like a story. It encourages them to engage. And by rendering Jupyter Notebooks, we can do that.
So one of the reasons why we host our curriculum on GitHub, and we are happy to work with other people who want to work on data education as well, is we really believe in giving back to the larger data science community. Pinterest is also a big believer in open source and giving back to the community at large. So today we want to talk a little bit about what are some of our future plans for how we'll be sharing our data science resources with everyone else. One of the things that's very fundamental to Pinterest's philosophy is Pinterest enables people to take action, to do. And the way we do that is by providing tools that are extensible. One of our founders is very passionate about Legos and the metaphor of Legos, the idea that you can have these very small building blocks that can be made into incredibly different things. We want to make sure that the things that we release help people to do more things with the data in their daily jobs. Later this year, Patrick and I will be open sourcing our current curriculum. So we've, in the past, done one-off workshops at conferences. We'll be open sourcing a publicly viewable version of our current curriculum, which is largely based on Pinterest data. So we need to make sure we have a data source available for you, which is why it's not available today. And later this spring, we'll be open sourcing the Jupyter Report Server, which has been incredibly instrumental to us making our sales team more data effective, to streamlining our engineering processes around evaluating things like experiments, and is generally a really cool tool. In closing, though, if I can get my clicker to work. Okay, there we go. Given that we've talked to you for about, 30, 35 minutes about the wonder of Jupyter Notebooks, I thought the thing we leave you guys with is a wish list item, given that we know there are lots of programmers in the audience. One of the things, Jupyter Notebooks is an open source tool. We have the features we have in it because of the contributions of individuals. One of the things that is still left to do, and this is just a great illustration of how early we are in the evolution of this tooling, is it's not actually very good to do code reviews today. It's not a perfect tool. So for example, if you do check into GitHub a notebook with maybe even a few edits, because the nature of how the notebook is represented on the back end is so verbose, you can get tens of thousands of additions, if not hundreds of thousands, for just small changes. And that's it. Thank you.
Yeah, thank you.